So we're all done now doing area and perimeter. So this is kind of like the summary to make sure that we really understand. So we're going to figure out what the area of this figure is in terms of writing it as an algebraic expression. And I think most of you would say, instead of going acrosswise, it might be easier to just go up and down. So that's what we're going to do. And when you move it up and down, you now no longer make this be 10A. So I'm just going to lightly cross it out because it's been cut into two pieces. So we need a length and a width for the big rectangle and a length and the width for the small. So the big one we already have is 5A by 5A minus 1. So length is 5A, width is 5A minus 1. The hard part will be finding this piece for the small. Now you'll notice this across here was 5A, so this was 5A across the top with that. All the way across is 10A, so 10A minus 5A is 5A. And I know it doesn't look the same, but you learned in geometry, looks can be deceiving. The mathematics are what are true. Now if you look over here, the big rectangle is 5A minus 1, but we want to remove this part. So I'm going to turn my paper and write right here. I want to do 5A minus 1 subtract 2A plus 3. And the thing is, I can't really do the subtraction. I need to do a distributive property with this negative sign. And because this is kind of weird, I'm going to keep my paper this way. I'm going to draw an arrow and write work out. So we have 5A minus 1. And now subtracting this whole polynomial means the 2A becomes negative, the 3 becomes negative. And that totals to 3A minus 4. And that is now our width for that small rectangle. And I wanted to write it on its side so that when we turn it back up to the front, it makes a visual what's going on there to remind us how we did it. Okay? So the small length is 5A and the width is 3A minus 4. If you need to pause to catch up, you can stop right now and copy all that down. All right. Well, we said the area is the area of the big times added to the area of the small, and we find the area by we find the area by length times width and length times width. So that's what I'm going to do now. So 5A times, and I like the area model, 5A minus 1, and then I'm going to do 5A times 3A minus 4. So in an area model, these are thought of as negative signs, even though when they're put in the polynomial, they're subtract signs. So 5 times 5 is 25. A times A is A to the power of 2. 5A times negative 1 is negative 5A. 5A times 3A is 15A squared. 5A times negative 4 is negative 20A. So if that was too fast, go ahead and pause it and catch up. To finish, the total area means we need to add these pieces. I'm going to highlight them so you can see them. We want to take these two answers and add them with these two answers. So we want to combine like terms. I have 25A squared minus 5a, adding to 15a squared minus 20a. And when I add those, I get 40a squared minus 25a. Done.